Okay, here's lesson 6 for measurement, surface area of pyramids and cones. So the first thing we're going to look at is the pyramid. We need to define some values here. So the first thing is the altitude. Now the altitude runs from the vertex to the center of a side. Okay, so that is the altitude. And the base is the value that kind of intersects with the altitude. Okay, so the surface area formula is length times width. So that's the square base. And 2AB, that's the 4 triangles. All right. Now a cone has a special formula. It's pi r squared. That's the circle. And then that is the lateral area. Now you do need to use the slant height, which is that part. Okay, the vertical height would go from like the very vertex to the center of the circle. Okay, so let's try an example here. The formatting is a little messed up, but the base is 10 by 10, and the altitude is 18. So if we go back to our surface area formula, that's length times width plus 2 times the altitude times the base value. So that is 10 times 10 plus 2 times the altitude, which is 18, times the base, which is 10. All right, so let's punch that in. So 10 times 10, that part's 100. And then 2 times 18 times 10, that gives us 360. So in total, we have 460 centimeters squared. Here's another example. Calculate the surface area of the following pyramid. So we got to do a couple things. We know the vertical height going straight. I'm just going to change my pen. We know the vertical height is 7.2, and the distance from the center outwards, we need to figure that out. But we can use that using 5, which is the base value. So 5 goes from there to there, which means that 5 goes from there to there as well. So we need to go back to our Pythagorean Theorem and look at this triangle. We know that the vertical height is 7.2. We know that all the way across is 5, which means that from the center out is going to be 2.5. And we need to figure out this, which is the slant height. All right. So if you recall, a squared plus b squared equals c squared. So 2.5 squared plus 7.2 squared is equal to c squared, or the hypotenuse. So 2.5 squared plus 7.2 squared, that equals 58.09. But we don't want the square, we want the square root. So if we take the square root of that value, the slant height is 7.62. All right. So let's use that in our formula. So again, the formula is length times width. That gives us the square base plus 2 times the altitude times the base. Okay. So the square base is just 5 times 5 plus 2 times the altitude, which we figured out to be 7.62, times the base, which is 5. So let's figure this all out. 5 times 5 plus 2 times 7.62 times 5. And all in all, we have 101.2 meters squared. All right. You need to look back and get pi r squared plus pi rs. Okay. So pi times r, the radius. So the diameter is 7, so the radius is half of that. So times 3.5 squared plus pi times 3.5 times the slant height, which is 11. Okay. So let's punch this into the calculator. Pi times 3.5 squared plus pi times 3.5 times 11. 159.4 centimeters squared. Okay. So we have an ice cream cone that has a diameter. So if you were to kind of draw in the entire diameter is 3, which means the radius is 1.5. 3 divided by 2 gives us 1.5. All right. It has a height, so a vertical height of 7. Determine the outside surface area of the cone or the lateral surface area. So I'm not really worried about the top of the ice cream cone, just the lateral surface area. So the formula is pi r squared, which gives us the circle part, plus pi rs, which gives us the slant height. We don't need the circle part, so you can cross that out. What we do need to figure out is the slant height. Okay. So let's draw a little triangle. The vertical height is 7. The radius is 1.5, so that gives us the this part here. And we're going to use a squared plus b squared equals c squared again. So 7 squared plus 1.5 squared equals c squared. So 51.25 is equal to c squared. Take the square root, and we get 7.2, which is what we need to use in this formula. So surface area is pi times the radius times 7.2. So let's multiply this value. (7.2) times 1.5 times pi, and we get 33.9 units inches squared. Okay. So we are going to do a composite figure including pyramids and cones. So if you recall from the last lesson, you do both formulas, so you split up the shape. So here we have a pyramid, and here we have a prism. Let's highlight the area that overlaps. So that part overlaps. So you do both formulas, and then you subtract twice the overlap. All right. So let's look at the pyramid first. So if you go back to the pyramid formula, length times width plus 2ab So we need to figure out this distance. Well, if you look over here, it's 6, and that's also 6. So the length times the width is 6 times 6 plus 2, and the altitude is given as 11. We don't need to use Pythagorean theory, times the base, which is 6. So let's calculate all that. So that's 168 centimeters squared. Now let's do the prism. So that surface area, you have to go back a couple lessons, but it's going to be 2 length times width plus 2 width times height plus 2 length times height. So that's our length, width, or height and width. Okay, so 2 times 13 times 6 plus 2 times 6 times 6 plus 2 times 13 times 6. So all of that comes out to 384. All right, so we have this value, 384, which is the prism. We have 168, which is the pyramid. Now we need to do the overlap. Well, the overlap is a square. So it's 2 times 6 times 6. Okay, so 6 times 6 would give us the area of 1 square. You double it. So that is 2 times 6 times 6. So 72 is the overlap. So the total, you're going to add 384 plus 168, but you're subtracting that overlap. If we do all that, we get 480 centimeters squared. Okay. From the surface area of this object to the nearest tenth, so we have a cone, we have a cylinder, and we got to figure out the overlap. Okay, so the cone is pi r squared plus pi rs. The cylinder is 2 pi r squared plus 2 pi rh. We'll figure out the overlap after. So pi times the radius of the cone. So if you look here, the entire diameter of the cone is 6, which means the radius is 3. Okay. And we do need to figure out the slant height. Okay. So we need to figure out this slant height, which means we're going to have to use Pythagorean Theorem. So let's do it down here. So the vertical height from the diagram is 4. This part's 3, and we need to figure out that. So 3 squared plus 4 squared equals c squared. That's 9 plus 16 is c squared. So 25. If we take the square root of that, oops, that's the square root. So the slant height is 5. Okay, so that means this line from there to there is 5. Okay, so let's use that in our formula. Okay, so if we do all that, we're going to get this answer. So pi times 3 squared is that, plus pi times 3 times 5. So 75.398. Why not? Okay. Now let's do the cylinder. So the cylinder is 2 times pi times the radius of the cylinder. So the cylinder has a different radius. The diameter here is 10, so the radius is 5 for this one. So we're going to use 5 squared plus 2 pi times 5 times the height of 15. So 157 plus 2 times pi times 5 times 15. So this one in total has a surface area of 628.3 meters squared. Now we need to figure out the overlap. So the overlap is 2 circles. So pi r squared times 2. And it's that circle there. So the radius was 3, so 2 times pi times 3 squared is the overlap. So 56.5. So if we do the total, this is a lot of math here, but it's going to be these two things added and then subtract the overlap. So 75.398 plus 628.3 minus 56.5. And we'll get a total of 647.2 meters squared.